Hey guys, Mr. Martin with a video, area under a curve with rectangles. Alright, so for part A, we have to sketch a graph for this function. I've pre-drawn my graph, so when we'll say t is 0, it's at 30 seconds. When t is at 3, it's at 37, and so forth. I'll give you a moment to catch up to me. Okay, so for part B, we are to estimate the distance traveled by the car during 12 seconds by finding the areas of four rectangles drawn at the heights of the left endpoints. This is called a left Riemann sum. So for part B, we want to add the area of this rectangle, this rectangle, this rectangle, and this rectangle. So the area under the curve is actually the entire area on this curve, but below it. So the area that the purple rectangles generates is an underestimate because its function is above the area that the rectangles generate. So we can write it right here. So the area of a rectangle is just length times width. So we've so designed the function so that the width of every rectangle is 3, because this is 0 to 3 to 6 to 9 to 12. So every rectangle has a width of 3, and the length of the rectangle is, because it's a left Riemann sum, is the height of the left endpoint. So our area is, for the first rectangle, is 3 times the left endpoint is 30 plus 3 times 37 plus 3 times 45 plus 3 times 54. So if we're looking at our graph, that's 3 times 30 for this rectangle, 3 times 37 for the second rectangle, 3 times 45 for the third rectangle, and 3 times essentially 54 for the fourth rectangle. So if you have a calculator, you can get it out. What's this? 90 plus 111 plus 135 plus 162. So 201, 336, 498. Let me check on a calculator. 90 plus 111 plus 135 plus 162, 498. All right, so this is an underestimate. So for part C, we're doing the exact same thing, but we're using the right endpoints as our rectangle heights. So if we go back to our graph, it's going to be this rectangle, this rectangle, this rectangle, and this rectangle. But the height of the rectangle is determined by the right endpoint. If we're looking at our table, it's just going to be 1, 2, 3, and 4 for our rectangle lengths then. Length and our width. So for part C, we'll get A equals 3 times 37 plus 3 times 45 plus 3 times 54 plus 3 times 65. So if we put this all in the calculator, we have 3 times 37 plus 45 plus 54 plus 65 is 603. So these rectangles go above the function, so we expect this area to be an over estimate. For part D, we're to use two rectangles drawn at the heights of the midpoints, and this is called a midpoint Riemann sum. So let's see. If we have two rectangles, we'd have one rectangle. You can't see what I'm drawing. So we have one rectangle here and a second rectangle drawn here. So the midpoint would be right here. Actually, you want the other midpoint, excuse me, to go up so that we get the other midpoint to be right here. So that's going to be at 3 and at 9 because each rectangle is 6 units wide. So the midpoint would be at 3 and 9 respectively. So our area is going to equal, so this rectangle, this blue rectangle is 6 units wide, and we're using 3 as the height, the y value at 3 for the height. So that's going to be 6 times 37 plus this rectangle also with a 6. And we're going to use the y value at 9 for the height, so plus 6 times 54. So 37 plus 54 is 91 times 6, so 546. So 546. So these are the three methods for approximating area with rectangles. We have a left Riemann sum, which uses left endpoints. We have a right Riemann sum, which uses right endpoints. And we have a midpoint Riemann sum, which uses the midpoint of a rectangle. On the back, we have the function y equals x squared plus 1, and we want to estimate the area bounded by the graph from x equals 0 to x equals 2. So let's see. Let's 1. We'll say this is 1 and this is 2. So 1, 2. Let's see. When x is 0, y would be 1. When x is 1, y would be 2. And when x is 2, y would be 5. All right, we're going to draw this kind of poorly and say this is 5. So should be a slight curve because it's a parabola, but I didn't draw it well. Using a left Riemann sum with n equals 4 subintervals. So that means that to have equal subintervals, each rectangle is 0.5 wide. So we'll need to have a rectangle here and another rectangle here. So 1, 2, 3, 4. So using left endpoints, we're drawing purple. So then another one would go here. Another one would go here, and the last one would go here. So this is 0.5, 1.5, and 2. So let's see. Area equals, so the width of each rectangle is 0.5. We're just going to take a shortcut and add all of the heights at 0, 0.5, 1, and 1.5. So At 0, the height is 1 plus at point 0.5, the height would be 0.5 squared, which is 0.25 plus 1. So that would be 1.25 plus the height at 1 is 2. So 2 plus at 1.5, 1.5 squared is 2.25 plus 1 is 3.25. So zero point 0.5 times 1 plus 1.25 plus 2 plus 3.25 is 3.75 times zero point 0.5. Oh, we already multiplied by 0.5. So this is just 3.75. If we're going back and using right Riemann to make a right Riemann sum, then we have a rectangle here, another rectangle here, another rectangle here, and another rectangle that goes down here. But the process is the same. The area equals the width, which is 0.5, times each one of the respective lengths. So at 0.5, we had 1.25. So 1.25 plus 2 plus 3.25 plus this right end point is 5. So that's 0.5 times 1.25 plus 2 plus 3.25 plus 5. So we get 5.75. So this area is, again, an overestimate because it's outside of the curve. And so last is we want a midpoint Riemann sum with 4 subintervals. So that means that from, what can I draw this in blue? So imagine we have the midpoint here, another midpoint here, another midpoint here, and another midpoint here. So instead of being at 0.5, we have a value at 0.25, 0.75, 1.25, and 1.75. So instead of calculating all these values by hand, let's go to y equals, we'll do x squared plus 1 for the second table, and then we'll do plus 0.25. So now each one of our rectangles is still 0.5 units wide. So we'll have area equals still 0.5 because of the width, but the heights are the y values at 0.25, 0.75, 1.25, and 1.75. Again, at 0.25, 0.75, 1.25, and 1.75. So using our table, at 0.25, the height is 1.0625 plus at 0.75, 1.5625 plus at 1.25, 2.5625 plus at 1.75, 4.0625. So 4.0625. And we'll just add all that up, multiply by half. So 0.5 times 1.0625 plus 1.5625 plus 2.5625 plus 4.0625. Make sure I have all these values correct. 1.0625. Okay. We end up with an area of 4.625. So far it seemed as if the midpoint Riemann sum gives us the closest area to the area that's under the curve. In our last example, you know what? Actually, we will do in class. All right. So that concludes our video on rectangles and area under curves using rectangles to approximate the area.